Assalamu alaikum guys, welcome back. Okay, so let's see how the electronic configuration works. Actually, how are you gonna write down the electronic configuration for any element in the periodic table? Alright, so we are in A-level chemistry and it's lecture 8 now. Okay, the electronic configuration. So how are you gonna write down the electronic configurations? In this lecture, we are gonna talk about the electronic configuration plus the Hund's rule and Aufbau's principle for writing down the electronic configuration, because these are the very important principles that you should know as well along with this electronic configuration. And Aufbau's principle in particular would make it even easier for you to write down any electronic configuration. So let's begin. If you guys go back to your O levels, remember how you used to write down the electronic configuration. Remember in O levels, if you had sodium 11 for instance, 11, how are you going to write down the electronic configuration for 11? 11 means 2 electrons in the first shell, 8 electrons in the second shell, and 1 electron in the third shell. This was the electronic configuration you used to write in O levels, right? Now in A levels it's going to be different. It's not this electronic configuration that we are going to follow. It's actually the more advanced electronic configuration in the form of, it's an electronic configuration that will tell you how the electrons are organized or present in different orbitals of different subshells and shells. So basically the electronic configuration will give us an idea of the electron shell, basically the shell in which the electrons are present. Remember the orbits, the energy levels, shell, same thing. It will give us an idea of all the subshells. It will tell us about the subshells which are there, the subshells in which the electrons are present. It will even tell us about the number of electrons which are there. And of course the number of electrons, we knew the number of electrons from our Convector 281 for electronic configuration as well, but this gave very little information about the shells and the subshells and the orbitals. So now this electronic configuration that we are gonna write will tell us about the shells, subshells and electrons as well. So let's begin now. First of all, 1s1 right over here, this is how you're going to write down the electronic configuration. This 1 represents, this number 1 over here represents the principal quantum number. Okay, this S represents the subshell. Remember I told you there were 4 subshells, but we are going to talk about the first 3 only, because the 4th one is not considered in our syllabus, because we don't get such questions in which F is also involved, because it's a very big orbital and then it requires special learning. It is going to become a bit very extensive basically. So in our syllabus we leave out the F orbital or the F subshell. Okay, it's important for you guys to just know that there is an F subshell there, and it contains 7 orbitals, 7 F orbitals, and containing 14 electrons. That's it. You don't need to know anything beyond this knowledge about F or subshell. Now coming back to our original subshells or original subshells. The S subshell contains 1 orbital, the 1 S orbital only. The P subshell contains P orbitals, and there are 3 P orbitals in the P subshell. And then the D subshell contains 5 orbitals, and there are 5 D orbitals in the D subshell. Okay, I told you the P orbitals, the 3 P orbitals have their own particular names, PX, PY and PZ, whereas the D orbitals also have their own names, the DXY, the DYZ, the DXZ, the dx squared, dxy, dxz, dyz, dx squared minus y squared, and dz squared are the names of the d orbitals that we have in the d subshell. And so now how you are going to write it down, basically for instance I have an atom over here. This is the nucleus of the atom, and this is the first shell. Okay, and this is the first electron. So how am I going to write down the electronic configuration of this atom? Meaning let's assume it's hydrogen atom. Okay, hydrogen, you know that hydrogen only has 1 proton and 0 neutrons and 1 electron, right? So 1 proton and 1 electron. So how are you going to write down the electronic configuration of this 1 electron? Basically this 1 is in the first shell or first principal quantum shell, so the value of n is going to be 1. It's because it's the first principal quantum shell. You are going to write down the number of principal quantum shell first. Then in what orbital is it present? What orbital is it present? This is the S orbital. The first shell always contains 1 orbital, and that is the S orbital. So it's the S orbital that it has. And in the S orbital, how many electrons do you have? You only have 1 electron. So 1 is going to become the power of this S. So this is the electronic configuration of hydrogen. That's it, nothing else. Similarly, now let's go beyond hydrogen. Let's write down something bigger. For instance, if we have, now this is our nucleus, this is our first shell containing 2 electrons, and then this is our second shell containing 1 electron, for instance. Now what would happen, we've got the first quantum shell and the second quantum shell, right? In the first quantum shell, we've only got 1 orbital, right? 1 orbital means that it's the s orbital that we have in the first quantum shell, right? So to write down the first, we are going to write down the electronic configuration of the electrons present in the first orbital. So it's going to be the principal quantum number is 1 for the first shell, and then they are present in what subshell? The subshell is s, right? And s contains how many electrons this time? It contains 2 electrons, so 2 over here. Then after this 1s2, we still have 1 electron left, but it's in the next quantum number or next quantum shell. So we are going to write down the quantum number after this 1s2. Quantum number is 2. And then after writing down the quantum number, we are going to write down the orbital, sorry, the subshell now. The subshell that we have, in 2, we've got actually we've got 4 orbitals. 4 orbitals. Remember, I told you in the previous lecture that we've got 1 s orbital and we've got 3 p orbitals, right? So in this 1s and 3p, meaning we've got 1s along with the px, py and pz. Now what we are going to do is, you're going to just first write down the s orbital. Why am I writing down the s and not the p? Because s is at a lower energy than the p orbital. So s is going to be filled first. So this s has 1 electron, right? The outermost shell has 1 electron. You just write down a 1 over here. Because why didn't I write down the 1 over here in the first 1s? Because first of all, it's in the next subshell, sorry, in the next quantum number, and secondly, the first one cannot have more than 2 electrons. Remember? So that's why. So this is going to be the electronic configuration of this element over here. Now, just now I told you that the s orbital is going to be filled before the p orbital because it's at a lower energy level. That is the Aufbau's principle. Aufbau's principle over here, it states that the orbitals which are at a lower energy level, they will be filled first, and then the orbitals at a higher energy level will be filled later on. So what do we mean by this? Let's look at it. I have written down the electronic the orbitals over here. In the first shell, the first quantum number, basically quantum number being 1, we've got only 1 orbital. Remember, I told you in the next shell, in the second shell, we've got how many orbitals? We've got 4 orbitals. 1 is present in the s subshell and the 3 are present in this p subshell. Okay, in the quantum number 3, how many orbitals do we have? 3 squared is 9. Remember, the formula for calculating the number of orbitals was n squared. So 9 orbitals. So 1 plus 3 plus 5 is 9, right? Remember, the d subshell contains 5 orbitals. Similarly, as you go down, it's going to become 16, 25 and so on. But I'm not writing down the rest of it because it's irrelevant to us. It's not a part of our syllabus. But over here, what you actually need to know is how are you, in what pattern are you going to fill in these orbitals, okay? So first of all, let's start out from the top. The very first orbital to be filled is going to be the 1s orbital. Okay, the 1s orbital. Why 1? Because it's in the principal quantum number 1, and why s? Because s is the only subshell in the first quantum number. Okay, this is going to be filled first. So I'm just going to put an arrow over here in this form, and I'll explain why I put an arrow over here. Then this 2s, after the 1s, the 2s will be filled. Okay, because s is at a lower energy than the p. Remember, I gave you this example over here. So this 2s, you're going to put another arrow passing through the 2s now. Then the 2p will be filled after the 2s, and then the 3s will be filled after the 2p. Why 3s is at a higher energy than the 2p? Because it's in the next quantum number. Okay, so the 2p will be filled after the 2s, and then 3s will be filled. After this, you're going to put in another arrow passing through the 3p and the 4s, because after the 3s, the 3p is going to be filled, right? And after the 3p, the 3d will not be filled. Okay, the 3d will not be filled. The reason for that is because the 3D contains 10 electrons, and the 10 electrons are at a higher energy level as compared to the 4s orbital. The 4s orbital contains only one orbital, right? That is the s orbital, because the s subshell contains one orbital, whereas the d subshell contains 5 orbitals, 5. So the 5 orbitals are gonna be at a higher energy as compared to the 4s. So therefore the 4s will be filled before the 3d. Then after this you keep drawing in the arrow, and the length of the arrow will keep on increasing. So after the 4s comes the 3d, then the 4p, then the 5s, then after that comes the 4d, the 5p and the 6s, and after that lastly 4f, 5d, 6p and 7f. This is how you are gonna fill in the electrons. Okay, so now according to this law, this is what according to this Aufbau's principle, you know the sequence of the different orbitals that you are going to write down in this electronic configuration, the sequence of whether you'll get the 2p first or 2s first. So you'll look at this orbital and it's the 2s which is before the 2p, so you're going to write that down. Okay, so I'm just going to write it down in a straight line. You always have to fill in the 1s orbital first. After the 1s is filled, okay, how many electrons do we need to fill in the 1s orbital? We need 2 electrons, so fill in the 2 electrons. After the 1s is filled, the next orbital to be filled is the 2s. Just keep following the arrows from tail to head. Okay, so it's the 2s that you'll need to fill. How many electrons can we have in the 2s to completely fill it? We will need 2 electrons. Okay, after the 2s comes the 2p. Keep following the arrow. Okay, keep following the arrow this way, this way, this way and this way from tail to head. After the 2s comes the 2p. Okay, you just go over here and 2p. Now, how many electrons can the 2p orbital contain? The p subshell contains 3 orbitals, px, py, pz. I'm not going to write down the px, py, pz separately over here. Okay, it's not the rule. According to the rule, you just need to show the p over here, and the total number of electrons that this p subshell can contain. How many electrons can it contain? It can contain 6 electrons because it contains 3 orbitals. You're gonna just write down, and the maximum number of electrons that this p can hold are 6. So 2p, 6 is gonna be the electronic configuration in order to completely fill it. And now if you look at it, this is kind of familiar. If you add in the 2 and the 6, how many electrons do we get? We get 8 electrons. Remember, in the second shell we had a maximum of 8 electrons. We cannot have more than 8 electrons. And in the second shell we don't have more than after p we don't have a d in here according to the n squared formula, because we only have a maximum of 4 orbitals over here. Okay, we don't have a d, so that's why we're gonna proceed on to the next quantum number after the 2p. So after the 2p comes the 3s. This is the 3s. Okay, it's an s orbital. How many electrons can the s contain? 2 electrons only, right, to fill it. Then after the 3s comes the 3p orbital. Okay, how many electrons can the p contain? P contains again 6 electrons. After the 3p, the 3d will not come. Okay, you keep following the arrow. After the 3p comes the 4s. 4s will be written before the 3d, and then after the 4s comes the 3d. And now, guys, this is an important point to understand, that the 4s will come before the 3d because 4s is at a lower energy than the 3d. Although the quantum number of 4s is higher than the 3d, it's 4 and this is 3, but still the s orbital has only 2 electrons and the d orbital has 10 electrons. So the 10 electrons are at a higher energy than the 2 electrons that this 4s contains. So the 4s will be filled before the 3d, okay, and then the 3d, the 10 electrons of the d will come after this 2 is filled, okay, and then you keep on going and going and going. After the 3d will come the 4p and then the 5s. After the 4p is filled comes the 5s. After the 5s is filled, 4d, 5p, 6s. Then 4f, 5d, 6p and 7f. And in the f orbitals, you can have a maximum of how many electrons? 14 electrons. A total maximum of 14 electrons, okay? But anyways, in our syllabus, we never need to go to the 4f. The electronic configurations that we have to deal usually end up till the 4p. We don't need to go beyond the 4p, but you should know how this Aufbau's principles work. Okay, you start out from the 1s orbital first, then comes the 2s, the 2p, 3s, 3p, 4s, 3d, 4p, 5s, 4d, 5p, 6s, 4f, 5d, 6p, 7f. Okay, so according to Aufbau's principle, you add in the electrons into the orbital which is at a lower energy. Now, according to all of this stuff that we've learned so far from the Aufbau's principle, let's apply it to writing down the electronic configurations, the actual electronic configuration, and this is the most important part of this video. Right, so now chlorine has a proton number of 17. It's an atom, so it contains 17 electrons as well, because you know that the atom is an electrically neutral species. Now this 17 electrons, if you were in O levels and I would have asked you to write down the electronic configuration of chlorine, how would you have given me the answer? It would have been 2, 8, 7, right? 2 plus 8 is 10 plus 7 is 17. Why 17? Because in the first shell, of course, in the first shell of chlorine, you've got the 2 electrons. In the next shell, you've got the 8 electrons. And in the next shell, after the 8 electrons, you've got the 7 electrons, the last 7 electrons, right? But now in A levels, I told you, you have to write down an electronic configuration that should give us the complete information about the orbitals and the subshells and everything else that's in there, right? Not just the number of electrons that are there. So for that, we are going to use this electronic configuration now. So to write down the 17 electronic configuration, first of all, we'll need to fill in the first shell, right? The first shell of chlorine. Let's just draw in the chlorine again. These are the 2 electrons in the first shell. These are the 8 electrons in the second shell. And these are the 7 electrons in the third shell of chlorine. Now, let's talk about the first shell first. First shell contains an electronic configuration of, okay, the quantum number is 1. And the first shell contains an s orbital, and that's the only orbital in there. So we are going to start out from the 1s orbital of according to the Aufbau's principle as well. In this 1s, we are going to add in that first 2 electrons, right? These are the first 2 electrons that we have in the first shell. So we are, okay, these 2 electrons of the first shell have been dealt with. That's it. You are not going to do anything about the first shell after this. Then you are going to jump on to the next shell. The next shell means the principal quantum number of 2. In the 2, the s orbital needs to be filled first, and then comes the 2p orbital. So you're going to write down the 2s over here. And as soon as you write down the 2s, you're going to fill in the electrons of the 2s. How many electrons can we have in the 2s? 2s2. After the 2s comes the 2p. Now, according to Aufbau's principle, after 2s comes the 2p. In the 2p, how many electrons can you have in the 2p orbital? You can have a maximum of 6 electrons. So you're gonna plug in the 6 over here. So the 8 electrons of the second shell have also been added, right? You've done the adding, you've dealt with the second shell as well. 2 plus 6 is 8, right? The 8 electrons in the second shell are also added in the electronic configuration with the complete information about the quantum number and the complete information about the shell or the subshell in which they are present. And after this second, we are going to jump on to the third one, right? Now, after the 2p, which is the orbital that needs to be filled after the 2p? Is a 3s orbital. So, I don't have space over here, so I'm going to write it down. In the 3s, again, it's an s orbital, right? It's an s subshell, so we can have a maximum of how many electrons? It's just 2. And after the 3s comes the 3p, because this arrow ends over here, the new arrow is going to start from here, right? You're going to go down. So now in the 3p, how many electrons are we left, by the way? Remember, we dealt with the first 2 shells. Now in the third shell, we've got 7 electrons. Out of the 7 electrons, 2 have been accommodated here. So 5 electrons left, right? 7 minus 2 is 5. So you are going to add in the last 5 electrons in the 3p subshell orbital. 3p subshell basically. Okay? It's not completely filled, and of course it won't be completely filled because the outermost shell is incomplete, right? It's not the 8 electrons that we have, or the 18 electrons basically that we have. So it's just the 3p5, and that's it. That's the electronic configuration of chlorine. Get it? Simple? Okay. This is how you're going to write down, and if I were to write it down in a straight chain fashion, so it would have been 1s2, 2s2, 2p6, 3s2, 3p, 5, and that's it. That's the electronic configuration of chlorine. So in your exams, if you are asked to write down the electronic configuration of chlorine, then this is what you need to write. Okay, and it's simple of those principles application over here. Then let's talk about sodium. Sodium has 11 electrons. So for the 11 electrons, start out from the Aufbau's principle, 1s. How many electrons do we have? 2 electrons in the 1s. Of 2 electrons gone, 9 left. Okay, out of the 9, after the 1s comes the 2s. Again add in the 2, because you cannot have more than 2 in the 2s in the s, right? Then after the 2s2, how many electrons have we added, accommodated so far? We have accommodated 4 electrons, right? 4 electrons, 11 minus 4 means we are left with only 7 electrons. We are still left with 7 electrons. Out of the 7 electrons, we can add in the 6 in this p, because p can have a maximum of 6. We cannot have more than 6 electrons in here. We add in the 6 over here, we are still left with 1 electron. For that one last electron, after the p comes the 3s, right? So you're gonna add the last electron to the 3s1, and that's the electronic configuration of sodium. Simple. After sodium, let's talk about magnesium. It's 12. So the entire thing is going to stay the same for magnesium, but we've got, instead of this 1, we're going to have a 2 over here for magnesium, right? Because we've got 12. If you count the total electrons over here, so 2 plus 2 is 4 plus 2 is 10 plus 2 is 12. So we've got the 12 electrons, right? After the magnesium comes the chromium and copper. Now these are the 2 exceptions to the rule, and we are going to talk about them here, of course, here. Now chromium, it has 24 electrons in total, right? 24 electrons. So 1s2, 2s2, 2p6, 3s2, 3p6. Now after the 3p comes the 4s, right? So it should be expected that it's going to be 4s2 and 3d4, right? If you count the electrons, it's going to be 2 plus 2 plus 4, 4 plus 6 is 10, plus 2 is 12, plus 6 is 18, plus 2 is 10, and plus 4 is 24. Sorry, plus 2 is not 10, it's 20, and plus 4 is 24. Now, this is what you should expect according to the Aufbau's principle, right? That you're going to fill in the 4s first, and then you're going to fill in the 3d, right? But, guys, this chromium is an exception, by the way. Chromium does not completely follow the Aufbau's principle, and it doesn't follow the Aufbau's principle in this part, 4s and 3d, because the 3d subshell over here, this chromium, what